FSA. So what are the states of A? So to answer part A, the different states are U, V, Y, and Z. The second part, what are the input symbols? A, B, and C. The next part, what is the initial state of A? That's where the arrow goes in, which is U. The accepting state or states is where the double circle is, which is at Z. And then the next state function that begins at a state Y with an input of B goes to V. And now draw the transition diagram. So we're starting with U where the arrow comes in. We have V, Y, and Z with a double circle. Then with an input of A, U goes to Z. With an input of B, U stays at U. With an input of C, U goes to Y. Y with an input, V with an input of A and C stays at V. And with an input of B goes to Y. Y with an input of A goes to Z. And with an input of B goes to V. And with an input of C stays at Y. And Z with an input of A and C stays at Z, but with an input of B goes to Y. And that's a transition diagram. The next one again is an FSA, and this is where we're designing an automatic teller machine, an ATM. The only digits that we're using in this problem are 0 through 7, and we're looking for the personal identification number to be 4732. So we're starting at S sub 0, which is where the arrow comes in. If the first number is a 4, it goes to S sub 1. If the number is a 7, it goes to S sub 2. If the correct number is a 3, it goes to S sub 3. And if the correct number is a 2, it goes to S sub 4, and that's where you get your money. However, there's also a state, S sub 5, which is incorrect. It's a trap state. And that means with any of the digits except 4, we would go to the trap state. Any digit except 7 goes to the trap state from S sub 1. Any digit except 3 from S sub 2 goes to the trap state. Any digit except 2 goes to the trap state. And once you get your money, we're also going to the trap state. And then there's an arrow here that once you're in the trap state, you are stuck there. And so you need all of this diagram to do an ATM correctly. All of the arrows, all of the states with the circles, double circle at S sub 4, an arrow coming in at S sub 3. Number 4 is a minimum spanning tree. And there are two different approaches to the problem, either Kruskal's or Prim's. I'm going to start with Kruskal's, and that is I'm going to choose an increasing order. So I have a 3 and a 3. So far I have 6 for the minimum weight. Then I'm going to look for the next smaller number, which is a 4. Now I have 6 and 4 is 10. Now I never want to have a cycle, so I'm not going to use the 9 in the triangle 3, 4, 9. And now I can choose either of the two 6s here, but not both, because it would complete a cycle. So now I have 16. So I'm never going to use the 6, never going to use the 9, and never going to use the 8, because they all form a cycle. Then I have a choice of either of the two 7s, which in fact I'm going to use both of them, because the purpose of a minimum spanning tree is to make sure that every one of the vertices has been used and that we have a minimal connection. Like networking computers would be a minimum spanning tree. And so the minimum weight is 13, and that's the number that you need. Excuse me, the minimum time here is, or the minimum weight is 30, not 13.